Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 1-4 Part 1 homework solutions on solving linear equations in three variables. To start off this problem here with these three variable equations, I'm going to start by trying to get rid of one of the variables in two of the equations. So let me start by labeling my equations 1, 2, and 3. And in terms of variables that I think it would be easiest to get rid of, x looks like it would be very easy to get rid of if I'm going to be doing this with elimination by adding things together, because I've got x, I've got negative x, so I could just add those together right away. This 2x would be pretty easy to get. So let me go with x. So for my first step, I'm going to add the e1 and e2 together here. Just straight up add them together as they are. So copy and paste e1. Copy and paste e2 over here, and then if I add these together, these x's are canceling out. And that leaves me with 3y minus 1z equals 7. I'm going to come back to this equation, which I'm going to call e4, but now let me add some other things together and create a second equation with just two variables of y and z. So I didn't use e3 yet. I'm going to do something that uses that. There's a lot of options I have here. If I wanted to, I could multiply e1 by negative 2, and that would do the job. But if I just multiply e2 by positive 2, that'll give me a negative 2x, and that will also suffice. So I'm going to do the second of those things. I'm going to multiply e2 by 2, and then add that to e3. And I'm going that route just so I don't have to mess with multiplying everything by a negative number. So going back to e2 and just doubling everything here, we've got negative 2x, which is important, plus 4y plus 2z, and equals 4. And then e3 is staying the same, so I'll just drag that over to here. Adding these together, we've got the 2x's canceling. This gives us 7y. 2 minus 1 is going to be 1z plus 13. And I'll call that equation 5. All right, so here are my two equations, 4 and 5. If I add these together as they are, I always have to check this, will anything cancel out? Well, actually, it looks like the z's are going to cancel. So let me just go ahead and do that. I mean, if it doesn't have to be hard, why make it hard? So I'm going to add e4 and e5 together. So I'm just going to take them and copy and paste them down here just so I can get them a little more organized. And now these z's cancel when I add these equations together. 3y plus 7y is 10y, and 7 plus 13 is 20. Dividing by 10, I get y equals 2. That's the first of my three variables that I had to find. So I'm going to go ahead now and plug this 2 back into one of these equations that only has two variables. I'm thinking e4 is probably the easier of the two. Although, then again, e5 doesn't have a negative z. Which way am I going to go here? I'm going to go with my first gut impression. Let's go with e4. So plugging 2 into e4 for y, we've got 3 times 2 minus z equals 7. So then that's 6 minus z. If I subtract 6 over to the other side, that's a 1 over there. And if negative z equals positive 1, then positive z equals negative 1. And then last but not least, let me plug y and z back into equation 1, would make the most sense. Not as much going on there. And that'll let me solve for x. So I've got x plus 2 minus 2 times negative 1 equals 5. So this is going to be x plus 4 equals 5. And then subtracting 4 gives us 1. So just writing all this out as a single three-part point here, we've got 1, comma, 2, comma, negative 1. In this problem, we're trying to solve this three-variable system of equations. So taking a look at variables I might try to eliminate in the beginning, I see that we have 2x in all three equations. So I'm thinking I should be able to add these together in a way that gets rid of those x's very quickly. One way I could do this is if I just multiply one of these equations, really any of them, by -1 and add it to another. Those two x's are going away. So the way I'm going to do this specifically, and let me just label my equations here, E1, E2, and E3. I'm going to do E1, and then I'm going to add that to -1 times E2. So I'll multiply E2 by -1 and then add it with E1. So there's what I'm doing, E1 basically minus E2. E1, I'm going to copy and paste that here. And now for E2, let me negate all of these. So that's going to be -2x plus y minus z equals -2. And now just add these together. That cancels out the x's there, the two x's. And then I've got 3y plus, this will be 4z equals 4. So there's one of my two variable equations that I need to set up to go further in this problem. For my next collection of things I'm going to be adding together, I'm going to multiply E3 by -1. And then I can just add it to, well, it doesn't really matter, I'll add it to E1 again. And I'll call this last one I got E4, just so I can keep track of that equation for later on. So now I'm doing E1 plus -E3 or minus E3. So E1 again, I'm copying and pasting that. And then E3, let me negate all of these now. So -2x minus 4y plus 3z equals -14. Adding those together, x's are going away again. Now I have 2 minus 4 for a -2y, and 5 plus 3 gives me 8z, all of that equaling 6 plus -14 or -8. And I'll call this one E5. So taking a look at E4 and E5, we've got the same two variables. And if I want to get rid of another variable here, it's looking like these z's are going to be pretty easy to get rid of, because I can just multiply this one, for example, by -2, and that would give me a -8z, which would cancel with the +8z. I could work on the y's as well, but it takes multiplying each equation by a number versus just this one equation. So let me do that then. I'm going to do -2e4 plus e5, unchanged. So -2 times e4 is giving me -6y minus 8z equals -8. And e5, I'm just copying and pasting that down there. So now adding things together, these z's are going away. We have a -8y equals -16. And now I can just simply divide by -8 to get y equals 2. Now that I have one of my variables, I'm going to plug that back into one of these equations to get another variable. I'm thinking E4 looks a little bit easier to plug things into. So I'm going to plug 2 in for y in E4. So that gives me 3 times 2 plus 4z equals 4. So that's 6 plus 4z. And if I subtract 6, that's -2 over there. And now if I divide by 4, I've got -1 over 2 if I reduce that. And I probably should. Okay, so now I have y and z. I'm going to plug both of those back into one of my original equations. Now out of the three here, the one that looks like it might be the easiest to work with is this E2, just because I have fewer coefficients that are not 1 in this one. So let me plug all that back into E2. I've got 2x minus 2 for y, and I have a plus z, so plus -1/2. Combining the -2 and the -1/2, that's going to be negative, let's see, 4 over 2 plus 1 over 2, that's -5 over 2. And then if I add that to the other side, I'm basically doing 4 over 2 plus 5 over 2, which is 9 over 2. And then finally, dividing both sides by 2 is the same as multiplying by 1/2. So I've got 9 over 2 times 1 over 2 is 9 over 4. So there's my x value. So putting it all together into a complete point, I've got 9/4, comma 2, comma -1 over 2. On this problem, I'm looking at variables that I want to try to cancel out with each other. And out of all of these, there's actually a few good options. You really could go with x, y, or z here and work it. It would work out pretty well. I'm going to choose to focus on y. but really any of those would work out fine. So if I multiply this first equation by 2, that'll give me a negative 2y, which will cancel out this positive 2y in the second equation. So let me label my equations, 1, 2, and 3. And let me do 2 times equation 1 plus equation 2. So that's going to be 8x minus 2y plus 4z equals negative 36. And now for E2, I'm just going to copy and paste that as is. Adding these two equations together, the y's are going to cancel out. So that leaves me with 7x. And this is going to be 4 and 1 is going to give me 5z equals negative 25. So there's one of my two variable equations that I need. Now to get the other equation, I noticed that if I multiply this first equation by 3 instead of 2, negative 3y would cancel out with the 3y in the third equation. So let me do 3 times e1 plus e3, and let me call this e4 while I'm at it here. So 3 times e1 plus e3, that's going to be 12x instead of 8x now, and then minus 3y plus 6z equals, let's see, 3 times 18, negative 54. And then e3, I'll just copy that as is. Adding these equations together, the y's are canceling. This is 12 plus 3x is 15x. And then we have 6z minus 4z is 2z. And then negative 54 and 44 gives us negative 10. And I'll call that equation 5. So these two equations, I have to solve these ones now. We've got the same two variables left. What would be easier to get rid of? Well, I'm thinking the z's look a little bit nicer because I just have a 5 versus a 2. So 5 and 2, those both go into 10. So I'm going to make one of these positive 10. I think if I multiply this one by 2, I get positive 10z. And if I multiply this other one by negative 5, I'll have a negative 10z. So I'm doing 2 times equation 4 plus negative 5 times equation 5. So 2 times equation 4, that's going to be 14x plus 10z equals negative 50. And then for equation 5, we're multiplying all these by negative 5 now. So this is going to be negative 75x minus 10z, and this will be equals a plus 50. So it looks like the z's are canceling out. 14 and minus 75 is going to give us negative 61x, and then 50 and negative 50 is 0. Well, dividing by negative 61, that's just going to be 0. So that gives me one of my variables. And now I'm going to go ahead and plug this back into one of these two variable equations to get another variable. I'm thinking equation 4 looks a little bit easier. I mean, they're both kind of the same. It doesn't really matter. Let me go with equation 4. So 7 times 0 plus 5z equals negative 25. So that's just 5z equals negative 25. Dividing by 5, we get z equals negative 5. All right, so let me plug 0 and negative 5 now back into an equation that has 3 variables, one of these in the start here. Let me just go with equation 1. It's as good as any. 2 might be easier, but I don't really care. So we've got 4 times 0 minus y plus 2 times negative 5 equals negative 18. 4 times 0 is just going away. This is going to be a negative 10 over here. We still have a negative y. Adding negative 10 to the other side, that's going to be negative 8. And then we divide both sides by a negative to get y equals positive 8. So putting all that together, this is going to be a solution of 0, comma 8, comma negative 5. For this last homework problem, this one's a little bit different than the other ones because we have y equals a bunch of stuff. This first equation is not in what we would call standard form, where you have an x plus a y plus a z equals a number. So you've got a few options at this point. One option would be to actually substitute 2x minus 6z plus 1 for the y's in these second two equations here. And that would be one way to get rid of the y variable. But I tend not to go that route unless we have y equals like a single number or a single expression. It's kind of messy. So I'm just going to label all of these like I always do, E1, 2, and 3. And I'm actually going to rearrange equation 1 to get the variables on one side and the constant on the other. So that'll be my first step. So I'm going to keep the 2x minus 6z where they are and just subtract y over to be with them. And then I'm going to subtract 1 over to the other side. And I'm going to write it on the right side, but it's really going over to the left side here. So that all equals negative 1. Now at this point, just looking at things that I could easily try to cancel out, it's looking like my best bet between these three equations here is going to be to deal with the y's, because I have a negative 1y here that I feel like I can leverage that pretty easily against the 2y and the 3y. If I multiply this equation 4, I'm going to call this, if I multiply this equation 4 by 2, that'll give me a negative 2y, which I could use to cancel out with this positive 2y. So let me do 2 times equation 4 plus equation 2. So 2 times equation 4, we've got 4x minus 2y minus 12z equals negative 2. And then adding that to equation 2, I'm just going to cut and paste that down here. So these y's are going to cancel when I add these equations together. 4x plus 3x is 7x. These z's add up to negative 7z. And then negative 2 and 16 is 14. So there's one equation I can use later on. Let me get another one of these two variable equations though. This time around I'm going to involve this equation 3 that we haven't really looked at yet. So I'm going to use equation 4 again, but now I'm going to multiply equation 4 by 3. And that'll give me a negative 3y that I can cancel with this positive 3y. Now before I do any of this, let me label this equation that I just came up with as 5 because I'm going to refer to it later. But now multiplying equation 4 by 3 and adding that to E3, let's do that. So that's going to be 6x minus 3y minus 18z equals negative 3. And let me copy and paste equation 3 over here. So adding these, we get the y's to go away. 6 and 7 gives me 13x. Negative 18 and negative 4 is negative 22z equals 8. And I'll call that equation 6. All right, so these are the two equations, 5 and 6, that I have to play off of each other right now. Now, it's not really great numbers to work with if you're trying to cancel things out. So this is really more of those pick a direction and grit your teeth and go with it. I'm going to choose to get rid of the x's here. I don't know, I mean these are both prime numbers, so that means that their least common multiple is just going to be whatever you get when you multiply 7 and 13 together. So I'm just going to multiply this first equation by 13, and I'll multiply this other equation here by negative 7, and then I'll get a positive and negative version of the same thing. So let me do that. 13 times E5 minus 7 times E6. Again, let's grit our teeth here. So 13 times E5, 7 times 13, well, 7 times 10 is 70, 7 times 3 is 21, so that's 91 overall, so 91x, minus this will be 91z, so that at least is the same. What's 13 times 14? I mean, I could use the calculator, but I know 13 times 13 is 169. Add another 13 and we've got 182. I'm just being lazy. I don't feel like going to Desmos for this. Now let's do 7, negative 7, times equation 6. So we have negative 91x in that case. Plus, this is going to be, let's see, 154z equals negative 56. So that wasn't totally horrible. Let me add these together. X's cancel. Negative 91 and 54, I believe that is positive 63z. And 182 plus negative 56, that's going to be 132 minus another 6 is 126. So it took us a little bit of mental math, but this is actually a nice situation because if I divide by 63, I get z equals exactly 2, which is awesome. Let me plug that back in now and see if I can get another letter. Let me go back into equation 5 here. So I've got 7x minus 7 times the 2 that I just found for z equals 14. So this is 7x minus 14. Add that to the other side, we get the 28 here. And then dividing by 7, I have x equals 4. And then finally, plugging 2 and 4 back in, I'm going to go with equation 1. Because this one actually works out pretty well. 1's been fairly useless for most of this because it was in the wrong form, but you'll notice we have y already isolated, and that's exactly the variable we're looking for. So hey, if they're going to hand that to me, why not? So we've got 2 times 4 minus 6 times 2 plus 1. That is 8 minus 12 is going to give me negative 4, plus 1 is going to give me negative 3. So my final answer then, I've got 4, comma, negative 3, comma 2.